Hey guys, so now we will going to discuss about spherical aberration. In the previous video we have discussed about chromatic aberration, that was the problem associated with polychromatic light, right? And that was mainly due to the refractive index of the lens or the refractive index of the material on which the lens is constructed, right? So here the aberration is due to the spherical surface. Remember, in the previous video I have told you that a lens is a transparent refracting medium made up of two surfaces, one of which must be spherical, right? And the using of spherical surface during the construction of the lens creates spherical aberration. Okay, although we are using spherical surfaces to construct lens in most of the cases. Okay, so that is the idea, that spherical aberration is mainly due to the spherical surface of the lens, and it is also applicable for monochromatic light. Okay, and the chromatic aberration is due to polychromatic light, and it is due to the refractive index of the matter, depending on which different wavelength of light refracted at different way, right? So spherical aberration occurs when light rays passing through the periphery of the specimen are brought into a focus that is not exactly to what we get when the rays passes through the center. Okay, that means the focus for the light rays coming through the periphery of the lens and the focus for the light rays coming through the center are not same. Okay, similar in case of those things also. So that's why what I have written here, that spherical aberration occur when light rays passing through the periphery of the lens are not brought into exact focus with those passing through the center of the lens. Okay, and as a result, what will happen? As a result, we will not have a well defined image plane. Okay, and as a result, the image is not correctly focused, or more specifically saying, the specimen is not correctly focused. Okay, so as a result, a point source of light appears as a light spot with bright halos surrounded by it, or series of diffraction rings when we are using the best focus of microscope, or when microscope brought into its best focus. Okay, so that is the idea. That means, due to the spherical nature of the lens, light rays passes through the periphery of the lens are not brought into exact focus with those passing through the center of the lens. Okay, and as a result, a well defined image plane is not formed. Okay, and as a result, the specimen is not correctly focused and creates a blurred image, okay, that cannot be easily studied. So for example, here we have provided an example that due to this spherical aberration, a point source of light appear as a light spot with with bright halo surrounded by it. Okay, or also you can get diffraction ring when the microscope is brought into its best focus. Okay, so more specifically, when our specimen has a significant thickness, it will gets blurred in such a amount that it becomes very much unrecognizable, especially at the periphery of the view field. Okay, so that is the idea of the spherical aberration, that spherical aberration leads to the blurred image, especially at the periphery of the view field, and this is due to the spherical surface of the lens. Okay, which prevent, or which due to which a well defined image plane and not exist. Okay, so another important defect is coma. Coma is similar to our spherical aberration, and coma is especially encountered with off axis light rays, and is most severe when the microscope is not, or is out of proper alignment. Okay, so that is the spherical aberration and coma. So both are same. So spherical aberration is for due to the spherical nature of the lens, as a result of which a well defined image plane is not formed, and as a result the specimen is not well focused. That is why a point source of light appear as a light spot surrounded by bright halo or diffracting rims when microscope is brought into its best focus. Okay, and more specifically, the complex specimen with a good level of thickness are often so blurred as to be unrecognizable, especially at the periphery of the view field. Okay, so that is the idea of spherical aberration, and coma is similar to spherical aberration. Here coma is generally encountered with off axis light rays and is most severe when the microscope is out of proper alignment. Okay, so that's it for today. So today we have completed our microscopy lecture series. So we will going to discuss about an out of syllabus microscopy, that is our scanning tunneling microscopy. We will going to discuss it in some day later in any other videos. So till then friends, bye bye and take care.